Hello everyone. In this video we will learn about errors and approximation. What is an error? Suppose there is any function y equal to fx. Then x is known as the independent variable, y is the dependent variable. If we make a change, small change in x, that is suppose delta x. If delta x is a change in x, then there is a change in y also, and that is suppose delta y. Then can we write that y plus delta y is equal to f of x plus delta x? These changes are only known as the errors. So let's learn about the definitions of this. What is absolute error? Absolute error. The change in x, that is delta x only, is known as the absolute error in x. A change delta x in x is known as the absolute error in x. Relative error delta x upon x is known as the relative error. Percentage error if delta x is the change in x, then delta x upon x into 100 is the percentage error. When we talk about the derivative of a function y equal to fx with respect to x, then we write that dy by dx is equal to limit delta x tends to 0 delta y upon delta x, where delta y is an error in y and delta x is an error in x. Delta x and delta y are very small. We can also write from this that delta y upon delta x will be equal to dy by dx plus epsilon, where epsilon is a very small positive number, such that epsilon tends to 0 when delta x tends to 0. If we cross multiply, can we write this as delta y is equal to dy by dx into delta x plus epsilon into delta x? So we can say that delta y is equal to dy by dx into delta x approximately, since epsilon into delta x is negligible. Why it is negligible? Because epsilon is a very small number, delta x also is a very small number, and if we multiply two very small numbers, it becomes negligible. And like this, we can get the approximate value of delta y by applying the derivative dy by dx. And hence, the approximate value of y, that is y plus delta y, will be equal to f of x plus delta x equal to fx plus dy by dx into delta x. This is the way we can find out the approximate value of y when there is a small error in x. To understand the concept more clearly, we will discuss some of the examples on it. The first one we take, find the approximate value of root of 25.2. Find the solution of this. What we do, we will take the function y of x and that we will take as root of x, because here we want to find out the square root of a number. The number which is a perfect square and nearest to this we will take as the value of x. So we will write here, let x is equal to 25 and x plus delta x be 25.2. It means the error here in x is 25.2 minus 25, that is 0.2. Now we will differentiate this y with respect to x. Let's take it 1. So we write here, differentiating 1 with respect to x, we get dy by dx is equal to, that is d by dx of root x, or we can write this as 1 upon 2 root x. Now we will find out the value of dy by dx at the value of x, which is 25. So we get here dy by dx is equal to 1 upon 2 into root of 25, that is 1 upon 2 into 5, or we can say 1 upon 10, which is equal to 0.1. Now we know what is y. When x is 25, y is equal to root of x, that is root of 25, or we can say 5. We have got the value of dy by dx, we have got the value of y. Now we need delta y, the change in y. Delta y is dy by dx into delta x. dy by dx is 0.1 and delta x is 0.2, 0.2 we multiply, this comes as 0.02. It means after finding the value of delta y, we can get the value of y plus delta y, which will be the value of root of 25.2. And what is y? We have already got 5, plus what is delta y? That is 0.02. So it comes as 5.02. And hence we can say the approximate value of this is 5.02. So we write approximate root of 25.2 is equal to 5.02. This is the answer. This is the way we can find out the approximate value of a function. The next problem we discuss here is find the approximate value of f 3.01, where fx is 3x square minus 5x plus 2. To find the solution of such problem, first we will write the function, that is y equal to fx is equal to 3x square minus 5x plus 2. Then we have to find out the value of the function at 3.01. So we can take x plus delta x equal to 3.01 and x as 3. This implies that the error in x will be delta x is equal to 3.01 minus 3, that is 0.01. In the next step, we find the value of f3, and that will be 3 into 3 square minus 5 into 3 plus 2, which is 27 minus 15 plus 2, that is 29 minus 15, or we can say 14. Now we will find out the derivative of this function, that is dy by dx, and here it is 3 into 2x minus 5 into 1 plus 0, which is 6x minus 5. In the next step, we find the value of dy by dx at x is equal to 3, and that will come as 6 into 3 minus 5, 18 minus 5, that is 13. To find the value of delta y, now we can apply the formula dy by dx into delta x. dy by dx here is 13 and delta x is 0.01. So this gives you 0.13. So the approximate value of approximate f 3.01 will be y plus delta y, where y is 14 delta y is 0.13, so this comes as 14.13. This is the answer. One more example. The radius of a spherical balloon is measured as 8 centimeter with an error of 0.02 centimeter. Find the approximate error in its volume. So what we will do for the solution of this problem, we will consider the radius of the sphere or the spherical balloon be x. So we will write, let the radius of the balloon be x. Then what will be its volume? Then volume V will be equal to 4 by 3 pi x cube. To find the approximate error in volume, we have to differentiate this. So we write differentiating with respect to x. We will have dv by dx is equal to 4 by 3 pi into 3x square, which is equal to 3 and 3 cancel as 4 pi x square. Here it is also given that x is 8 centimeter and the error in it means delta x is equal to 0.02 centimeter. Now we calculate the value of dv by dx at x is equal to 8, which is 4 pi into 8 square, that is 4 into pi into 64 or 256 pi. Now to find out the value of delta V, we will apply the formula delta V is equal to dV by dx into delta x. dV by dx is 256 pi into delta x is 0.02. When we multiply it comes as 5.12 pi. Therefore, we find the error in volume is equal to 5.12 pi centimeter cube. This is the way we can find out the solution of the problems on approximate value. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.